All right, people, in this video right here, we're going to work on drawing something called Lewis structures, okay? And these Lewis structures are pictures of molecules. Now, we've drawn Lewis dot diagrams before, and that's really going to help us here, okay? Remember, all of these atoms are looking for the magic number of 8 valence electrons, okay? Now, let's take a look here at a blank periodic table and some things that we're going to need to think about. First of all, when we're drawing Lewis structures, these are molecules, all right? So it means they are covalently bonded, all right? So in other words, we're talking about these guys over here, aren't we? Now let's look at oxidation numbers real quick. Let's look at oxidation numbers. Okay, oxidation numbers, +1, +2, +3. And then here with carbon, plus or minus 4, nitrogen's -3, oxygen's -2, and fluorine's -1, okay? So we need to think about this. Let's zoom in on these groups right here, okay? Carbon. Carbon is in the plus or minus 4 group. And when we think about this plus or minus 4, we're thinking of ionic bonding, all right? But that's not what's happening here. We're doing covalent bonds. All right? So the math, we're not adding up this math like plus and minus math. We're thinking about it a little bit differently. But I can tell you that an atom of carbon would look like this on a Bohr model. It has 4 valence electrons. How many does it want? It wants to have 8. Instead of stealing electrons from other atoms, actually what it does is it shares electrons from other atoms. It shares them, okay? So we have another atom here. It would share them, okay? Now, carbon has 4 valence electrons, so carbon wants to share 4, okay? When you make a picture of carbon, it will end up with 4 lines drawn to it. What are these lines? A line is a pair of shared electrons. Now, I know a bunch of this sounds like garbage to you so far, but just stick with me. If we go back and we look at carbon's plus or minus 4, it wants to share 4 electrons to get up to 8. Nitrogen is -3. Let's look at a Bohr model of nitrogen. It looks like this. It's got 5 valence electrons. How many more does it need to get up to 8? It needs 3 more. So instead of stealing 3 more electrons from another atom, it may get near another atom and then share together those 3. So now nitrogen would feel like it had 8. So things in the nitrogen group are generally going to have 3 lines attached to them. Oxygen, it has 6 valence electrons, so it's going to need to share 2 more to get up. Fluorine group, it has 7, it's going to need to share 1 more. I know you don't quite understand this yet, so let's just keep doing it. Let's take a look here at carbon. Okay? Let's draw the molecule carbon dioxide. All right? Carbon dioxide. Carbon wants to have 4 lines drawn to it. Every oxygen wants to have 2 lines drawn to it. Why? Carbon needs to share 4 more electrons to get up to 8. Oxygen needs to share 2 more electrons to get up to 8. If we try to draw a molecule and we want to give carbon 4 lines and oxygen 2 lines, well, we can actually pull that off. If it's CO2 and you draw it like this, then both of the oxygens, they have the 2 lines they're looking for, and the carbon has the 4 lines it's looking for. Now let's count the electrons. Every line counts as 2 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So this carbon, it's happy. let's look at this oxygen. It's sharing 1, 2, 3, 4. So it's going to need to have its other 4 electrons drawn, and they'll occur in pairs, okay? Mr. Perkins, it seems like you drew a pair up here and a pair here at an angle. I did. All of this group of electrons and these electrons and these electrons, they're all trying to stay away from each other. So that's why I put the electrons at this angle. They're all negatively charged, so they're all repelling each other. Over here on the other side, we'll draw 2 pairs of electrons for that guy. And let's count the electrons. 1, 2, 3, 4, 5, 6, 7, 8. That guy's happy. 1, 2, 3, 4, 5, 6, 7, 8. That guy's happy. 1, 2, 3, 4, 5, 6, 7, 8. That guy's happy. Carbon dioxide. Carbon dioxide is a linear molecule. All right, so let's break this down again. I'm going to zoom in on the right side of the table. We got boron. Let's go to carbon. Carbon's going to have 4 lines drawn to it. Nitrogen, most of the time, is going to have 3 lines drawn to it. Oxygen, most of the time, is going to have 2 lines drawn to it. And fluorine and these guys below are always going to have 1 line drawn to them. Now, this holds true as we go down, okay? But the ones on top are the ones that we'll be drawing the most. So let's think about this little thing here. Carbon being plus or minus 4, if it can share 4 more electrons, we'll end up with 8. Nitrogen already has 5 valence electrons, so if it can share 3 more, it'll end up with 8. Oxygen already has 6 valence electrons. If it can share 2 more, it'll end up with 8. Fluorine already has 7 valence electrons. If it can share 1 more, it'll end up with 8. Let's try to draw another picture. How about we try to draw a picture of an atom, of a little molecule. How about we try carbon tetrahydride? All right. Where do you think the H would fit on this? That's right. The H is sitting right here, so H is going to have 1. Okay. Carbon tetrahydride. There's only one way to draw this. Carbon would have to be in the middle. Carbon would have to be what we call the central atom. And the H's have to be on the outside. They're what were called peripheral atoms. The only way you could really draw CH4 would be like this. Now, do we need to draw any extra dots for anybody? Let's see. Carbon has 1, 2, 3, 4, 5, 6, 7, 8. That's cool. The H's, they've got 2, 2, 2, 2. Remember, H doesn't go all the way up to 8. A Bohr model of hydrogen is only in the 1s, right? So only 2 electrons can fit on the inner shell of any atom. So H's are happy with only 1 line. But let's draw another tetrahedral molecule, CF4. What if I drew CF4? I would have a carbon as the central atom. I would have to spread my F's out all the way. And now the F's, they're not happy. They need the magic number 8. 1, 2, 3, 4, 5, 6, 7, 8, right? 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. Now everybody's happy. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And let's look at the carbon. 2, 4, 6, 8. Everybody's happy. That's all we're doing right now. The last thing I will tell you is we need to be able to label bonds as sigma and pi. Sigma is the first or the primary bond or the first bond, and pi would be either the second or third bond drawn, okay? Now, I know that you're like, what does this mean? Well, I'm not going to explain it to you in this video, but I will tell you this. Let's take a look at the molecule O2. Here's an oxygen, O2. We got to draw this. And we'll have another oxygen. Each of the oxygens is going to want to have how many lines attached to it? 2. So we can just do this. Boom, boom. And now let's add our extra pairs of electrons. 1, 2, 3, 4, 5, 6, 7, 8, off at an angle. 5, 6, 7, 8. Both of these oxygens now have 8. And now, if we're going to draw the sigma and the pi bonds, we'll label one of these as the sigma and any others as the pi. Does that make sense? Does that make sense to you? Both of the oxygens have 8. We have a sigma and a pi. The last thing that I'll say to you is sometimes molecules are written especially to help us draw them. Check this formula out. What about CH3OCH3? Okay, now if we were going to draw a Lewis structure of this, every carbon is going to need to have 4 lines. Every hydrogen is going to need to have 1 line. Every oxygen is going to need to have 2 lines attached to it. This carbon is going to have 4, and every hydrogen is going to have 1. Remember, we get the number of lines from this little chart. If you need to copy this little chart down real quick to help you with the homework, that would not be a bad idea, or just make a screenshot of this you can go back to. Look at the way this is written. We could just write C2H6O, couldn't we? But it's written like this. It's written like this to make sure you can draw it. The O is central. It's in the middle, so we're going to draw the O right here, okay? On to the left of the O, we're going to have a CH3. Well, there's really only one way to do it. We'll put a C in the middle. We'll put 3 H's around it like this. Do the same thing to this CH3 on the right side. C, H, 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 and then boom, boom. Check this out. What do you think about this picture? That H is happy. 2, 2, 2, 2, 2, 2 for all the H's. The H's only want 2. The carbon wants 8. 2, 4, 6, 8. 2, 4, 6, 8. This oxygen right here, 2, 4. There's going to be 4 more electrons left on this guy, aren't there? Because the oxygen only has 2, 4. So put 2 there. We'll put 2 there. Now the oxygen has 8. This is done. Are these sigma or pi bonds? Well, there's only one bond drawn every time. So all of these would be sigma bonds, okay? Good luck on this homework. I know this is all bizarre and strange, but watch this as you work. Do not send me a paper that says, I don't know how to do this. Just watch the video. Go back, play the video again, play it again, play it again, play it again. Right? You got me on video. You can jump through the video back and forth and try to figure out how to do these problems. Peace out. Good luck. You can do this.